When we talk about new materials, we're not just talking about innovation. We're talking about controlling nature at the atomic level. Boron nitride is a unique material. It combines lightness, heat resistance, and the stability that modern industry requires.
Its structure is hexagonal, similar to graphite. But the main difference lies in the arrangement of the atoms. Boron and nitrogen alternate, creating a perfect insulating structure. It does not conduct electricity, does not oxidize, and can withstand temperatures over 1000 degrees Celsius. This makes boron nitride a material that is as light as graphite and as pure as ceramic.
But the true strength of boron nitride lies in its ability to transform. Under high temperatures and pressure, it can transition into a cubic form. In terms of hardness, it is second only to diamond, and unlike diamond, it remains stable when in contact with iron. That's why cubic boron nitride has become a key material for abrasives and cutting tools.
In order to form cubic boron nitride, the starting material must be activated and ready for the reaction. And this is exactly where our AVSp unit comes into play. It's not just a mill, it's a system where physics and electromagnetism work together. Inside the housing, ferromagnetic elements move in a vortex field, striking, grinding, and activating the particles at incredible speed.
As a result, the boron nitride particles are not only ground down to micro and nanoscale sizes, but also acquire an activated surface. This is critically important for the subsequent synthesis of the cubic phase. The activated powder behaves differently. It reacts faster, more uniformly, and yields a higher degree of conversion.
We conducted a series of tests. After processing in the ABC, the degree of boron nitride transformation into the cubic form increased from 40% to over 70%. Such efficiency is unattainable in ball or jet mills. AVSp not only provides grinding, it changes the very energy of the material.
We can precisely control the process parameters, the field energy, the duration, and the speed of the moving elements. Thanks to this, we obtain a stable structure with a controlled grain size. For micropowders, this means uniformity, and for the manufacturer, predictability and consistent quality from batch to batch. The finer and purer the powder, the more precisely it performs in composites. Boron nitride micropowders are the basis for heat-dissipating substrates in microelectronics, where it is important to dissipate heat without conducting electricity. This is exactly what makes it possible to create reliable chips, transistors, and IGBT modules that operate under harsh temperature conditions. Boron nitride has a hardness of up to 9.5 on the Mohs scale. This opens up possibilities for creating grinding, polishing, and abrasive materials for ultra-precise processing of steel, carbides, on-particle boards, and lathes. And here again, the quality of the powder determines everything.
Everything we do is a combination of fundamental physics and precision engineering. When you see how ordinary powder becomes a material that can be used in aviation or microelectronics, you realize you're not just working with machines, you're creating the future. Boron nitride micropowders are a technology of precision, process stability, and confidence in the result. This is GlobeCore technology.